Morning, dear students. Today we will learn about how to solve the equations by using matrix determinant method, or we say Kramer's rule. In previous class we learned about how to solve the equations by using matrix inversion method. So today another method, that is we use determinants to solve the equations. So that is called Kramer's rule. So Kramer's means it is the name of the scientist who introduced this method. So objectives of the class are this PPT. On completion of this period, you would be able to understand the Kramer's rule, apply the Kramer's rule to find the solution of a system of linear equations involving three unknowns. Recap. What is a linear equation? An algebraic equation containing the first degree polynomial. Second, what are the non-homogeneous linear equations in two unknown x and y? a1x plus b1y equals to c1 and a2x plus b2y equals to c2. What does the solution of this linear equation means? It is the value of x and y which satisfy both the linear equations. What is the solution of these linear equations by elimination process? X equals to b2c1 minus b1c2 by a1b2 minus a2b1, and y equals to a1c2 minus a2c1 by a1b2 minus a2b1. What is the solution of the two non-homogeneous linear equations? a2x plus b2 a1x plus b1y plus equals to c1 and a2x plus b2y equals to c2 in x and y. It is the values of x and y which satisfy both the linear equations by using the elimination process. Here the solution is x equals to b2c1 minus b1c2 by a1b2 minus a2b1, y equals to a1c2 minus a2c1 by a1b2 minus a2b1. the solution x equals to b2c1 minus b1c2 by a1b2 minus a2b1 comma y equals to a1c2 minus a2c1 by a1b2 minus a2b1 can be expressed using determinants as x equals to det of c1 b1 c2 b2 by det of a1 b1 a2 b2 comma y equals to det of a1 c1 a2 c2 by det of a1 b1 a2 b2. The denominator in the values of x and y is the determinant of the coefficients. The numerators are the determinants obtained by replacing the coefficients of x and y respectively by the constant terms. Solution of linear equations by Kramer's rule. Solution of non-homogeneous linear equations, simultaneous linear equations by Kramer's rule. Consider the three non-homogeneous linear equations in x, y, z. So a1x plus b1y plus c1z equals to d1, a2x plus b2y plus c2z equals to d2, a3x plus b3y plus c3z equals to d3. Let delta equals to a1 b1 c1, a2 b2 c2, a3 b3 c3 not equal to 0 be the determinant obtained by the coefficients of x, y, z respectively. Then x into delta equals to x a1 b1 c1, x a2 b2 c2, x a3 b3 c3. Applying c1 gives c1 plus y c2 plus z c3. Applying c1 gives c1 plus, that is gives symbol is reversely printed here, so we have to change the direction. So applying c1 gives c1 plus y into c2 plus z into c3, we get x a1 plus y b1 plus z c1. See here, we are adding second and third column elements to the first column. Remaining second and third columns are as it is. So b1 c1, and next second row x a2 plus y b2 plus z c2 b2 c2, and last row x a3 plus y b3 plus z c3 b3 c3, that equals to d1, d2, d3. And second column b1, b2, b3, c1, c2, c3 from equation 1, and that equals to delta 1. Then x equals to delta 1 by delta. Here left side delta is multiplying. If it goes to right side, it divides. Similarly, we can say y equals to delta 2 by delta, and z equals to delta 3 by delta, where delta 2 we can say a1, a2, a3, and second column is d1, d2, d3, and c1, c2, c3. Here some printing is wrongly printed, so just the second column changes as a d1, d2, d3, and remaining a1, a2, a3, c1, c2, c3 same. And where delta 3 equals to third column replaced with d1, d2, d3, and the first column is a1, a2, a3, and second column is b1, b2, b3. Thus x equals to delta 1 by delta. Here delta is printed as a1 bar, so that is actually delta 1. Okay. Y equals to delta 2 by delta, and z equals to delta 3 by delta, where delta 1, delta 2, delta 3 are the determinants obtained from delta on replacing the first, second, third columns by d1, d2, d3 in each column respectively. So Gabriel Kramer is the introduced this method. Equation 2, giving the values of x, y, z, constitute the Kramer's rule after the Swiss mathematician Gabriel Kramer. So you can see his hairs are very long, different look is giving, and he born 31st July 1704, and he was died 4th January 1752. So nearly he lived 47 years, but his hard work is very appreciable, and his methods now we are using. That is a great thing. So next remarks. The solution x equals to delta 1 by delta, y equals to delta 2 by delta, z equals to delta 3 by delta gives a unique solution of the system of linear equations provided delta not equals to 0. Then the system of equations are said to be consistent. If delta not equal to 0 and delta 1 equals to delta 2 equals to delta 3 equals to 0, then the solution is x equals to y equals to z equals to 0. This solution is said to be trivial solution. The Kramer's rule can be generalized to the system of n linear equations in n unknowns. Kramer's rule does not apply delta equals to 0. If delta equals to 0 and at least one of delta 1, delta 2, delta 3 is not 0, then the equations will have no solution. Then the system of equations are said to be inconsistent. If delta equals to delta 1 equals to delta 2 equals to delta 3 equals to 0, then the system of equations will have infinitely many solutions. Application: unknown currents or voltages in electrical networks can be found by using Kramer's rule. Solved examples. First question: solve the following system of equations using Kramer's rule. In bracket, method of determinants. So we can say it is a determinant method or Kramer's method or Kramer's rule. X plus 2y minus z equals to minus 3. 3x plus y plus z equals to 4. X minus y plus 2z equals to 6. Solution: let delta equals to determinant of 1, 2, minus 1. From the first equation, we are taking the coefficients of x, y, z as a first row. Similarly, from second equation, we are taking the coefficients of x, y, z and writing here as a second row, that is 3, 1, 1. And similarly, third row, from third equation, 1 minus 1, 2. Expanding by R1, we know how to expand. First one is positive, and after eliminating row and column where the first element is there, then we have only 4 elements, then it's determinant. So 2 minus of minus plus, so 1 into 2 plus 1. Next, for second element we have to keep negative symbol. Minus 2 into 6 minus 1. After that plus, but third element here is a negative symbol, so plus into minus minus, so minus 1 into its minor, that is minus 3 minus 1, and that equals to minus 3, and that is not equals to 0. The system of equations are consistent because delta is not equals to 0. Then delta 1 equals to, in the delta we are replacing the first column with the constants in the equations of the right side, that is minus 3, 4, 6, and second, third columns are as it is from delta. 2, 1, minus 1, minus 1, 1, 2. Here also expanding by R1, so minus 3 of 2 plus 1. So how minus 3 of 2 plus 1 means minus 3 into its minor. So do next. First one is positive, but 3 itself has a negative symbol, so plus into minus minus. And come to the second element, so after positive we have negative sign, or you can say it's the cofactor. So that's why in the generally I already explained you how to find the determinant. So first one is positive and second element is negative in the first row, so minus 2 into its minor of the 2, so 8 minus 6, and plus of minus minus 1 into its minor, that is minus 4 minus 6, that equals to, to simplify we say minus 3. Next, delta 2. Here if you observe delta 1 is replaced with constants as a first column in the delta, and here delta 2 the constant terms comes in the second column in the delta, so that is replacing second column with constant, so we can say that is delta 2. Remaining first and second column as it is like in the delta, so delta 2 we can write 1, 3, 1 and minus 3, 4, 6, third column minus 1, 1, 2. So here also again expanding by R1, same procedure, and after simplification we get equal to 3. So delta equal to 3. And delta 3, in the delta we are replaced the third column with constants, then the changed determinant is called delta 3. In delta 1 first column changed, in delta 2 second column changed, in delta 3 third column changed. So the process to remember is very easy. Delta 3 means third column of the delta replaced with constants of the equations which are in the right side. So see here delta 3 equals to, column wise I am saying 1, 3, 1, 2, 1 minus 1, minus 3, 4, 6. Again here expanding by R1, then we can write 1 of 6 plus 4 minus 2 of 18 minus 4 minus 3 of minus 3 minus 1, that equals to minus 6. By Kramer's rule, can write x equals to delta 1 by delta, that equals to minus 3 by minus 3, that equals to 1. Minus minus get cancelled, 3 also get cancelled, so 1. And y equals to delta 2 by delta, that equals to 3 by minus 3. So 3 get cancelled, and in the denominator we have minus, so minus 1. And z equals to, you can say delta 3 by delta, that equals to minus 6 by minus 3, that equals to 2. Therefore x equals to 1, y equals to minus 1, and z equals to 2 is the solution. Second question. Solve the following system of equations by Kramer's rule. The equations are x plus y plus z equals to 9, 2x plus 5y plus 7z equals to 52, 2x plus y minus z equals to 0. Let delta equals to 1, 1, 1, 2, 5, 7, 2, 1, minus 1. And we already know how delta is formed. In previous question also we discussed it is formed from the equations coefficients. First coefficients as a first row. First coefficients means first equation coefficients. The second equation's coefficients we write in the second row, and third equation coefficients we write as a third row. And the elements are kept in a determinant that is called delta. And we are expanding by R1. Here brackets are not printed, but we have to kept. So that is 1 into minus 5 minus 7 is in the bracket, and minus 1 into minus 2 minus 14 should be in the bracket, plus 1 into, so 2 minus 10 should be in the bracket. That equals to minus 12 plus 16 minus 8. That equals to minus 4. That is not equals to 0. Now delta 1. So in the delta we are replace the first column with constant terms of the equations right side terms. That is 9, 52, 0. Remaining second, third columns are as it is from the delta. Now if we expand, here also brackets are not printed, are not showing, but we have to kept. Same, expanding by R1. There is not mentioning means expanding generally R1. So it is sometimes need not mention. So you can expand with any row, you will get same. But generally we expand first row. So 9 of minus 5 minus 7 minus 1 of minus 52 minus 0 plus 1 of half means here we have to open the bracket and close the bracket of its minor. So After simplification, we get minus 108 plus 52 plus 52, that equals to minus 4. And next come to delta 2. In the similarly, in the delta 1 we are replaced first column of the delta, and to form the delta 2 we replace the second column of the delta with the constant terms of the equations right side. So delta 2 we can write delta 1 2 2 9 52 0 1 7 minus 1. So in the delta second column is changed, that's why we are said delta 2. This is here also same, expanding by r1, and here brackets also not visible or not showing, we have to kept. So 1 half minus 52 minus 0 minus 9 half minus 2 minus 14 plus 1 into 0 1 half 0 minus 104, and that equals to minus 52 plus 144 minus 104, that equals to minus 12. Delta 3 equals to determinant of 119 2552 210, that equals to 1 half 0 minus 52 minus 1 half 0 minus 104 plus 9 half 2 minus 10, that equals to minus 52 plus 104 minus 72, that equals to minus 20. By Kramer's rule, x equals to delta 1 by delta, that equals to minus 4 by minus 4, that equals to 1. Y equals to delta 2 by delta, that equals to minus 12 by minus 4, that equals to 3. Z equals to delta 3 by delta, that equals to minus 20 by minus 4, that equals to 5. Summary. We have discussed about Kramer's rule. Solution of non-homogeneous linear equations in 3 unknowns using Kramer's rule. Quiz. Kramer's rule does not apply if here 4 options are given, A, B, C, D. So answer is when delta equals to 0. Second question, the system of linear equations x plus y equals to 5, 2x plus 2y equals to 7 will have, so 4 options, that is A, B, C, D, and the answer is no solution. You can easily observe, if you multiply with 2 to the first equation, we get 2x plus 2y equals to 10, but here it given 7. So by simple observation also we can say, otherwise if we found the delta, so 1122 means 0, so there is no solution. Third question, the system of linear equations x plus y equals to 1, 3x plus 3y equals to 3 will have, so infinitely many solutions. Infinitely many solution. Assignment. First one, the equations connecting the currents I1, I2 and I3 in an electrical network are given by 3I1 plus I2 plus I3 equals to 8, 2I1 minus 3I2 minus 2I3 equals to minus 5, 7I1 plus 2I2 minus 5I3 equals to 0. Calculate I1, I2 and I3 by Kramer's rule. Second question. Solve the equations x plus 2y plus 3z equals to 6, 2x plus 4y plus z equals to 7, 3x plus 2y plus 9z equals to 14 by using the method of determinants. So here in the assignment only few questions, 2 or 3 questions are given, but in the exercise we have some more questions in the textbook in this chapter. So see the textbook and first see the example problems and understand them and practice them, and do the exercise problems also after completion of this assignment work. And order wise write in the fair notes, because while you are writing in the fair notes, the order is you are mentioning means there is no chance to escape the question. So first practice in the rough notes, try in the rough notes. If you have any doubt, you ask me or you can ask your friends. You can mail me, call me, I will explain you. And if you know the solution, then if in your friends is there any one don't know the solution or is they have any doubt, you can clarify their doubts, you can help them, because you are helping means you are saying solution means you are the practice or you are the perfect in that topic. You will be very perfect, and it is practiced to you, and the solution is easy for you, because number of times you are saying means it is stays in your mind. So do each and every problem in exercise which are in the same method. That means now Kramer's rule we are discussed. So on that Kramer's rule, how many questions are there? So each and every we should do. So one more thing, you can cross check the solutions. That is, at finally you will get xyz values, and these values are, if you are substituted in any equation which are given in 3, it is satisfied. That means if it is satisfied means you are did correct. If they are not satisfied, the equations means you are did mistake in any step. That is, at delta 1 it may be, or delta 2, or it may be delta 3, or in simplification. So after finding the answers, cross check, and if it is not satisfied, if you are not knowing where the mistake is, then you can cross check with your friends. You and your friends delta values are same or not, and delta 1 values are same or not, and delta 2 and same or not, and delta 3 are same or not. If at any stage it is differ means, suppose delta 2 is you are getting 5 and your friend getting 6, that means either your friend done mistake or your side is mistake. So if you check the delta 2 once again, and you and your friend, then there is a clarity whose mistake is occurred at delta 2. So this is very useful if you discuss it with your friends also. So first do own, and is there any doubt, or if it is not satisfied, or it is what you are found the values is not satisfying the equations, means you can observe once again the steps each and every. In simplification part also, you are writing, or you can observe the positive signs, negative signs, whether sign is missed in any step. So this type of observation should be must if it is not satisfied. So after completion you can observe where the mistake has done, and if you ask your friends, then you can easily find where the mistake is happening. Suppose you and your friends delta 1 delta 2 are same. If delta 3 is differ, that means delta 3 at delta 3 you either you are mistaken or your friend is mistaken. So both are once again observe the delta 3 step by step, then you can easily find where the mistake has done. So this is how you have to cross check, and you have to find the error in where it is happened. So sometimes our solution is correct, then if we compare with our friends means, if it is differ, then it is helpful to our friend also, because if he had done any mistake, then it is definitely differ with our values. So suppose x values are same but y is differ, then he may go through the delta 2. If delta 2 is correct, then he may think about delta 2 by delta. Is it in the fraction or cancellation or simplification, or any plus minus symbol? If he forgot to keep plus or minus like this, you can or he can easily find the mistake. So practice, and this is very easy method, and the formula is also very simple. Remember, we can easily remember the method, and this method may come in exams because in previous years so many times asked this method. Total we have 3 methods from the matrix, and in previous class we discussed one method, that is inversion method, and in this class we are learned determinant method or Kramer's rule. And when you are listening the video, first you open the PPT, because every video contain PPT also, and if you want I provide PPT separately, because video contains the data very large compared to only PPT. So PPT is very less data occupies, that is memory occupies less, within 1 MB or 2 MB only. But where the video is it may up to 200, 300, 400 MB also, and every video is having PPT. So first open the PPT, see the PPT, you can easily understand, and then if you listen the video, then the remaining percentage is also cleared. And why I am saying see the PPT only first means sometimes in the video some screen clarity may missed or sometimes not visible properly. Then if you see the PPT means or if you open the PPT in another device and listen the video, then it is very convenient to you of the screen issues. So and note down the PPT content also in the running notes or in the rough notes, and practice. And if you have any doubts, you can ask me, mail me or message me, and do each and every problem. I will check your fair notes also. And thank you. Have a nice day.